Okay, so this is basically what we did on Monday and Tuesday, February 6th and 7th. So we're starting to talk about the Pythagorean theorem. So the goal that we have for today is that we want to be able to deduce the Pythagorean theorem.
Are you at home?
Sorry, I got interrupted. So basically what we want to be able to do is deduce the Pythagorean theorem, so kind of figure out what the Pythagorean theorem is. And then use the Pythagorean theorem to find unknown side lengths of right triangles. So all these squares and side lengths that we've been drawing, this is kind of what we've been leading up to. And so hopefully after we figure out what the Pythagorean theorem is, then we won't need to use all those squares anymore. Okay, so you eventually today you'll need that little sheet of paper that has the chart on it, and you'll need a page of dot paper, which hopefully should be on the website. But we've got this triangle here, and what we want you to recognize is that this is a right triangle. And we know that it's a right triangle because it's got this little square in the corner here. And so if you look at this, we want you to be able to understand that a right triangle has three sides. Two of those sides are called legs, and the third side is called the hypotenuse. So just by looking at the green figures, you should be able to figure out that these two pieces are the legs, and this one is the hypotenuse. So to kind of put a little bit of a more concrete idea to which ones are the legs and which one's the hypotenuse, the legs are going to be the ones that create the 90-degree angle, so they're the ones that touch the 90-degree angle, and the hypotenuse is going to be the one that's always opposite the 90-degree angle. And I always think of this little square in here as like a little arrow, and so it kind of points at what your hypotenuse is. So the legs create the 90-degree angle. Or the right angle, and the hypotenuse is always opposite the right angle. Okay, so that's just kind of the right leg in a nutshell. One thing to note is that the hypotenuse is always the longest side, no matter what. And the only time that we have a hypotenuse is when we're talking about a right triangle. So we don't really have an hypotenuse if we're talking about an acute triangle or if we're talking about an obtuse triangle, only with a right triangle. All right, so we have, if you look on page 31 of your book, there's a triangle in there already that looks like this. And what they're trying to get you to see is what are the lengths of the two legs of this triangle. So remember, the legs are the ones that create the 90-degree angle, so the legs would be these two pieces right here. And each one of those side lengths is 1 unit long. Okay? So each leg each leg is 1 unit long. Now, if we were going to draw if we wanted to find the length of the hypotenuse of this triangle, what we would need to do is we would need to draw a square, just like we've been doing. Draw a square off of the hypotenuse. Find the area of that square, and then take the square root of that to find what the hypotenuse is. And hopefully what we'll do today is we'll replace that to figure out what the shortcut is, which is the Pythagorean theorem. Okay? If you were going to draw squares off of each one of these legs down here, what would those areas be? Well, on each side your square would need to be 1 unit. So we would have a 1 unit square over here, and then we would have a 1 unit square over here. So the area of this one would be 1 unit, and the area of this one would be 1 unit.
If you're still in the building, please come to the main office. Anissa Alabegas, please come to the main office. Thank you.
Okay. So if we were going to find the area of this blue square right here that comes off of the hypotenuse, okay, what we would need to do is either draw our square around and subtract out the corner triangles, Or if we divide this up, we can see that there are 4 half triangles on the inside, and each one of those half triangles has a unit of 1/2 or 0.5. And so if we add all those together, half, 1, 1.5, 2, this square has a unit, or has an area of 2 units. So then if we need to find the length of the hypotenuse, if the area is 2, the length of the side, or the length of the hypotenuse, is the square root of 2. Okay? Now the area of the square that's on the hypotenuse is 2, which is this right here. Okay? So we have a square of length 1, we have a square of area 1, another square area of 1, and then this third square has an area of 2. So if you look at it, think about how those 3 squares are related. Think about how their areas are related. Okay? So what I'm going to have you do now is on your dot paper, and I'll kind of do the second one with you so that you kind of get an understanding of what we're supposed to be doing here. Okay, on your dot paper, you're going to draw a triangle, and it's going to have these 2 lengths right here as the lengths of its 2 legs, and then we'll have to draw the hypotenuse. So we want one length to be 1, and we want one length to be 2. So we're going to draw that on our dot paper. So one length needs to be 1, and it doesn't matter which one you choose as 1. And then one length needs to be 2. And remember, we're counting the spaces between the dots, we're not counting the dots themselves. So even though this has 2 dots, there's 1 space between, and even though there's 3 dots here, there's 2 spaces between. And then we have our hypotenuse, which is this right here. Okay? So what they're asking us to do now is to draw squares off of each of the legs, and this should actually be leg 2, not leg 1, so I apologize for that. But we're going to draw squares off of each of those sides. So back to our dot paper, we're going to go and we're going to draw a square. So this length right here is 1, which means that all side lengths need to be 1 because we're drawing squares. And remember, the properties of squares that they have 4 90-degree angles and 4 equal sides. And then we're going to do the same thing off of the other leg. We're going to draw, now this one is 2, so that means that all sides of our square have to have a length of 2. Okay? And then we're going to do the same thing off of the hypotenuse. So this one is over 1 and up 2, so up 1 and over 2, up 1 and over 2, and here's the hypotenuse square. All right, so now we're going to find that, if we come back to our thing here, we're going to find the area of each of those 3 squares, and we're going to fill in those values in these 3 spots here. So back to the dot paper page. If we look at the red one, the area of this, in order to find the area, remember you take the side length and you square it. So it's 1 squared, which is 1. So we're going to go back here and we're going to put a 1 in our chart. Okay, back to the dot paper. We know that this area right here is, the side length is 2, so in order to find that area we would take 2 and square it, so our area would be 4. So we're going to put that value right here. And then we're going to go back to the dot paper again, and we're going to find the area of this purple square now. So I'm just going to grab my green, and we're going to do what we have been doing before. We're going to find the area of the big green square. So this is 1, 2, 3 spaces. So the green one has an area of 9. And then we're going to subtract out all these corner triangles here. Okay, so remember, a triangle is base times height divided by 2. So 1 times 2 is 2. 2 divided by 2 is 1. So each one of these corner triangles is 1 unit. So if we subtract these 4 out, that means that the area of the purple triangle is 5. Okay, so if we come back to our paper here, the area of the square on the hypotenuse, remember the hypotenuse is opposite the 90-degree angle, is 5. Okay, so go ahead and continue to draw your squares. Now eventually what you should notice is that there's a pattern that forms. Okay, and once you find that pattern, you shouldn't have to draw the triangles anymore. You can just start to fill in these values right here. So take some time, as much time as you need, go ahead and pause for a little bit, and then when we come back, we'll have the chart filled in, and we'll talk a little bit about the pattern. Okay, so back to our chart here. If you have a triangle with two of the legs, 2 units each, the area of the square on the first leg here should be 4, and the area on the second leg should also be 4, and then your square on the hypotenuse should be 8. Okay. For the next triangle, you should have gotten an area of 1, an area of 9, and an area of 13. For the next one, you should have gotten an area of 4, an area of 9. Oh, I'm sorry, this previous one was not 13, that should have been 10. My mistake, sorry. And this one should be 13. For the next one, you should have gotten an area of 9, an area of 9, and an area of 18. And again, for the last one, you should have gotten an area of 9, an area of 16, and an area of 25. Okay, so one of the things that we've been talking about is that if you know the area of the square, you should be able to find the side length and vice versa. So in order to find the area, you take the side and you square it, and vice versa, if you're trying to find the side length, you take the area and you square root it. So if we know what the area is, all we have to do is find the square root, and that tells us what the length of the hypotenuse is, okay? So if we find the length of the hypotenuse, okay, if your area is 2, then your length of your hypotenuse should be the square root of 2. If your area is 5, then your side length should be the square root of 5. If your area is 8, square root of 8. If the area is 10, your side length is the square root of 10. If your area is 13, your side length should be the area of 13, or sorry, the square root of 13. If your area is 18, you should have the square root of 18 as your side length. And if your area is 25, your area would be the square root of 25, but the square root of 25 we know is just 5, so we would write our answer. Instead of writing it as the square root of 25, we would just write it as 5. All right, so here's where we're getting into it, okay? I'm going to give you a little bit of time to see if you can figure out what the Pythagorean theorem is in your own words. It's a formula, okay, so it's an equation basically that relates these 3 letters together, okay? So one thing to note is that A and B are always your legs, okay? When you label a right triangle, you're always going to label the legs with A and B. And it doesn't matter if you put B here and A here, or A here and B here. A and B are pretty much interchangeable, but C is always going to be the hypotenuse. And we already talked that C, the hypotenuse, is always going to be the longest one. So take a couple seconds, see if you can figure out what the Pythagorean theorem is. See if you can write something down. If you need to, think about this chart back here. This might also help you, okay? Okay, we're going to come back to this page here. Hopefully you had a little bit of time. If you paused it, that's good. We're going to let these 2 pieces be A and B, okay? And hopefully you figured out that in order to get from this column here to this column here, or from these numbers here to these numbers here, and from these numbers here to these numbers here, all you had to do was take 1 times 1. Because, okay, so all you had to do is square this one to get this one, square this one to get this one. So really what this column is a squared, and what this column is b squared. And then in order to get this last column, all we had to do was just add these together. So 1 plus 1 is 2, 1 plus 4 is 5, 4 plus 4 is 8, 1 plus 9 is 10, 4 plus 9, etc. You get the idea. So if we add these two together, we get this column over here. And now, because this is area, it needs to be squared. So you notice that it's a squared because it's the area. It's b squared because it's the area. So now because this is the area, and because it's the hypotenuse, now if you come back here, you remember that c is always the hypotenuse. So, oops, flip back, this is going to be c squared. Now, this right here is your Pythagorean theorem. So that is something really important. You might want to write it down, highlight it, draw some stars, unicorns, rainbows, hearts, whatever you want to put around it so that you know that that is super important. Okay? So what we're going to do is we're going to do a little bit of practice right now. I'm going to show you how to use it. So for example, let's say that we know that A is 3 and we know that B is 4. Okay? So if A is 3 and B is 4, all we're going to do is we're just going to plug those into the equation in the correct spot. So 3 is A, so we're going to do 3 squared. B is 4, so plus 4 squared equals, this side is always going to stay c squared. We're not going to do anything else with this side right here. It's always going to be c squared. All the math is going to happen on the red side. Okay? So remember that 3 squared is not 3 times 2. Remember that 3 squared is 3 times itself. So 3 times 3 is 9, 4 times 4 is 16, and again over here we're still going to have c squared. Okay? So now what we're going to do is we're going to add these two together just like we did with the chart back here. So this is like the square on leg 1, the square on leg 2, and then we added it together to get the area. So this is the square on leg 1, the square on leg 2, find the area. So now 9 plus 6 is 25. And that's still equal to c squared. Now, this part right here where it says 25 equals c squared, that's this part right here. Okay, so that tells us that the area of the square on the hypotenuse is 25 units. Okay, so what we need to do is we need to figure out what c is. Well, in order to figure out what c is, we have to take the square root. Okay, just like we did back here. When we were trying to figure out what the length of the hypotenuse was from the area of the square, we took 2 and we square rooted it. We took 5 and we square rooted it. We took 8 and we square rooted it. And what that gave us was the length of the hypotenuse. So we're going to do the same thing here. If this is the area, in order to find the length of the hypotenuse, we need to square root it. So what happens is the square root sign and the 2 cancel each other out, which leaves us with c over here. And we know that the square root of 25 is 5, so that gives us the 5 right here. All right, so I'm going to give you another one to practice. I want you to try this one on your own. We're going to say that B is 12 and A is 5. And again, you're still using Pythagorean theorem. A squared plus D squared equals C squared. Okay? So take a minute or two, pause the recording, and then try this one on your own. Okay, so hopefully you were able to get at least this far. Okay, so with this part, we plug the 5 in for A, we plug the 12 in for the B, and then square the 5. 5 times 5 is 25, 12 times 12 is 144. You add those two together, you get 169. So remember, what this one means is that this is the square that we would draw off. This is the area of the square that we would draw off of the hypotenuse. So in order to find out what what the length of the hypotenuse is we need to take the square root of both sides. So this and this are going to cancel out. So 13 is equal to C. So the length of the hypotenuse from here to here is 13 units. All right, let's try another one. I'm going to challenge you a little bit more this time. Okay, so this time we're going to let B equal 10, and we're going to let A equal 3. And once again, A squared plus B squared equals C squared. Okay, hopefully you were able to get this far. So again, this, when it's C squared, that would be the area of the square that we would draw off the hypotenuse. And in order to find the side length from the area, we need to take the square root of both sides. So we know that the 2 and the square root cancel out, so we get C is equal to. Now if you take 109 and you punch it in your calculator and try to find the square root, it's going to give you either a decimal or it's going to give you just this back. So anytime you get a decimal, anytime that it's not a whole number, you're just going to leave it as this. So our answer is going to be C is equal to the square root of 109. Okay, last one that I'm going to give you to practice, and then I have one for the dot paper that I want to show you, and then you can work on your assignment. All right, so last one. Let's let B equal the square root of 5. Let's let A equal 6, okay? And again, we're using A squared plus B squared equals C squared, okay? So take a couple of seconds, pause the recording, and then see what you come up with. Okay, this one should have been a little bit of a challenge for you because of this piece right here. So if you think about what happens when we are trying to find the square root, okay? The square root sign and the square cancel out. And so that's the same thing that happens in this piece right here. We talked previously about when you take a square root and you square it, then these two pieces right here are inverses of one another, and what you're left with is just the number that's underneath the radical sign. So that's how we get just plain old 5 here. We square the 6 to get 36, we square the square root of 5 to get 5, and it's still equal to C squared. So when we add these two pieces together, we get 41. And then in order to find, now this, remember, it would be the area of a square off of the hypotenuse if we were going to draw that, which we're not, we're done drawing, okay? So to go from the area to the side length, we just take the square root. Now, 41 again, if you punch that into your calculator and try to find the square root of it, it's going to give you a decimal. So you would just leave it as the square root of 41. These two are going to cancel each other out, and so you're left with square root of 41 is equal to C. Okay, one other thing. Actually, two really quick things. So, first off, what if we have 2 dots? If you remember, earlier we started on a map of Euclid, and we had like the grocery store and the gas station, and we were trying to find driving directions between those, and we were trying to find the driving distance and the distance that it would take a helicopter to fly. And so what we can do now is we can take a step backwards now, and instead of using all those driving instructions and using a ruler to find those measurements, what we can do now is we can use the Pythagorean theorem. So if you're trying to find the distance between 2 points on a map, or a grid or something like that, what you want to do is you're going to want to turn that into a right triangle, okay? And this part right here is going to be your hypotenuse. Pretend that it's straight and not curved, okay? So these two pieces here, and again, it doesn't matter where you put your A and your B as long as they're the legs. And remember, this is our arrow that's pointing to the hypotenuse, so this one is going to be C. Now when it's on dot paper, all we have to do is just count the length of this triangle here. So our length here would be 2, so B is equal to 2, and this is 1, 2, 3, 4, 5. So A is equal to 5. And now, A squared plus B squared equals C squared. So we know that A is 5. We know that B is 2. And we're looking to figure out what C is equal to. So 5 squared is 25. 2 squared is 4. And remember, this side doesn't change, so it's still C squared. We're gonna add these two pieces together to get 29, and the side is gonna stay c squared. Remember, this part right here represents the area of a square that we would draw off of the hypotenuse. So in order to go from the area to the side length, we just need to take the square root of both of those sides. And again, if you punch 29 into your calculator, it's going to give you a decimal, so we're just going to leave it as the square root of 29. The square root and the 2 are going to cancel each other out. So the distance between these two green points that we put up here is the square root of 29. Okay, one very last thing, I promise, and then I think we should be done. One other thing to note is that the Pythagorean theorem only works for right triangles. So if we have this square right here, we've done this one before, we know that the area here is 5. We know that the area of this one is 10, and you can do those calculations if you want to. The area of this is 25. So this is a squared, this is b squared, and this is c squared. So we know that if the Pythagorean theorem is true, a squared plus b squared should equal c squared. Well, if we plug these into this formula over here, a squared is 5, b squared is 10, c squared is 25. Is that a true statement? No, so that means that this is not a right triangle and it doesn't work. All right. Well, I think these are the homework problems, and they are either in the book or I have them attached as PDF here. You don't have to do number 12. 38 to 39, 1, 2, 5, 6, 8, and 11.